Thank you. Bonsoir. Excusez-moi pour mon merde français. Does that make sense? Sorry that I have to speak in English or German, but not in French. I'm sorry. So the topic for today, unlocking observability in Apache Kafka-based systems with OpenTelemetry. My name is Harry Kimpel. I am from a company called New Relic. Anyone heard of New Relic before? Okay. Whatever I'm talking about today is not focused on New Relic. This is not like sales pitch or anything, right? I'll be focusing on OpenTelemetry. It's an open standard. I'll get to this in a second. I'm using New Relic to visualize the metrics and telemetry, but you can apply this anywhere else in any other observability platform. I have been a software developer pretty much all my professional career. I started in Microsoft ecosystem. Don't judge me for that. I know it's a Java user group, but I started in Visual Basic 3 and 4, so a long time ago. Anyway, I am with New Relic since 2017, started as a solution architect and am now in developer relations. And if I'm not in front of a computer, I like all the things outdoors. So this is a picture on where I live, south of Munich, Germany, basically at the border of Austria. So I do like hiking, biking, climbing, skiing, of course, this time of year. And this is also my skiing area that you see in the back. Anyways, no talk without AI, I guess. So I asked ChatGPT just recently, based on what you know about me, and ChatGPT has some kind of memory function, draw a picture of what you think my current life looks like. And it came back with this, here's an illustration capturing your developer life, inspired by the Bavarian Alps, blah, blah, blah. And this is what it came back with. And I thought this was amazing. It looks pretty much close to that, not exactly, but I thought this was an amazing, drawing of my picture. My daughter, I have a little daughter, 11 years old. She asked, how does ChatGPT know that you have so many monitors at home? And I'm like, I don't know. It's maybe guessing, hallucinating, but it is actually looking pretty similar like this. Anyways, who of you uses Kafka already? Okay, pretty much everyone. Who has heard about OpenTelemetry before? Okay. And keep your hands up if you're using OpenTelemetry today. Okay, a few. Nice. This is a topic that is near and dear to my heart. OpenTelemetry, for those who haven't heard about it, it's an open standard. Nowadays, part of the CNCF Foundation. It was actually a merger of two other projects, OpenCensus, that focused on the metrics, like different telemetry, and Open Tracing, focusing on tracing. And now OpenTelemetry really combines all the different types of telemetry, metrics, traces, and logs into a single standard. The good thing is that many companies, basically any hypervisor out there, Microsoft Azure, Google, AWS, they all are very much invested into OpenTelemetry. This will be the future and is already, in some cases, already today. We at New Relic, we also started in application performance monitoring, and we have our own agents. But my personal opinion, and I'm probably not allowed to say this in public, but I think these will go away at some point, and everyone will use OpenTelemetry because this is an open standard, and you can rely on this. It's no vendor lock-in, right? You can instrument your applications once, and then choose what you want to do with the data and all the telemetry that you collect. One nice thing, and I'll get through this in a second. By the way, are you interested in live demo or slides? I have both. Live demo? Okay, nice. So I have an example also on an OpenTelemetry collector that I have deployed. The nice thing about this is, as part of the OpenTelemetry ecosystem, it comes with this pipeline where you can send in your data, your telemetry, this is what you see on the right-hand side, into this pipeline from your applications, like this is a Java user group, from your Java applications, but also from any other language that you're using, Rust, Ruby, Go, .NET. And you can send your telemetry into this pipeline. You can then also, of course, send data from your cloud providers or other systems into this pipeline, or into multiple versions, multiple instances of this pipeline. And then the nice thing is that you have full control over what happens with that data, because you can encrypt the data, you can process it, you can, if you, by accident, captured some personal identifiable information, you can also mask this type of data before you send it out to any observability backend, like New Relic or Datadog or Dynatrace, or if you're using open source tools like Jaeger for tracing, Elastic for logs. This is also possible, but you have full control over what happens with that type of data, and you can send data anywhere or in multiple different instances. And this is a really nice construct that is pretty new, and that also comes with OpenTelemetry. And then the question is, let's just jump in everyone using OpenTelemetry, but there are some design considerations that, and this is also what I want to show you today on what the differences are in using OpenTelemetry, because typically there's two different ways on how you can get started. There's an easy way. This is what you see on the right-hand side. And I like this analogy. If I want to eat a cake, I can go to a bakery and buy a cake. I don't have to buy ingredients. I don't have to have an oven at home that I need to prepare and warm up. I can just buy a cake. But the caveat is, there's not much I can do about it. It's ready. Yeah, I can maybe decorate it, but if I'm allergic to peanuts and it has peanuts in it, it's probably not a good choice. But then on the right-hand side, you have like more the ingredients when you want to bake your own cake. And this is also what OpenTelemetry, kind of like the analogy, works. You have on the right-hand side your manual instrumentation. You have dependencies and SDKs and APIs that you can incorporate into your applications. Or you can use, and since this is a Java user group, you can use a Java agent that you can attach to your applications. And this is a zero code, no changes to your application type of way on how you can get started with OpenTelemetry. So there's one that is easy, no changes into your app, but it has limitations. And then there's the other way in where you have some dependencies in your application, but it brings some additional benefits if you use it. Does that make sense so far? Nice. So what I always encourage, and there's different types of support here. Again, this is a Java user group, and Java has great support for many years. This is a screenshot I took in 2023. The point that I want to make here is that OpenTelemetry is evolving quickly, and it has evolved over the time. I did many screenshots, and basically for many languages they have great support already. And when they pronounce anything as stable, that means that you can use it in production. It is ready. It is supported. Of course, it's an open source project, but there's many large vendors that contribute. We, as well as New Relic, we contribute to that standard. But I would always encourage you to check the docs, and I have another example later on when it comes to like frameworks that you're using. Always check the docs on OpenTelemetry, which is highly encouraged. So getting into the application that I have prepared for today. It is a pretty simple application. It's not very fancy. I have a Kafka application, so I have basically a producer that sends data into Kafka. I have a consumer that reads data from Kafka, processes it, and then I have a downstream service that is also instrumented using OpenTelemetry. It runs on some host. Basically, it all runs on my local machine here, and then I'm also having a call to some external service. This is not sure if you anyone noticed it, but there's a external service that you can use. Maybe I can make this a little bigger. So this is jasonplaceholder.com, and then you can just use that service. You can request users, and it's quite nice. And this is also what I embedded into this application, just to show you, even if you're using a third-party service like an API, you can still gather some data. And this is also what I quickly wanted to show how this works. All right. And then I have slides prepared, but I would like to go through this in like in a live demo, if you agree. Okay, so what I'm using for this is a tool called Instruct. This is not a tool from New Relic or anything. We just use this for demo purposes. The nice thing is that in this environment, everything runs in the browser. I can have a terminal here. I can have various kinds of instructions. And basically, I have deployed a Kafka environment into this. You can see I have a couple different containers running here. One is a Kafka container. Then I have Zookeeper running, and also an OpenTelemetry collector that I have running inside of this environment. So this is the basics that I already have deployed. And then I have the services that I mentioned on the screen, the producer, consumer, and that other downstream service. I have them, located here. We can have a quick look at the different services. It's really basic Spring Boot applications. I use the Spring Boot starter pack to create these. And then if I look into the application here on the producer side, I have a REST API endpoint that I can send some JSON payload to it using a post request. And then whenever I receive this, I'll send this into a Kafka template and send it to a topic in Kafka. This is what the producer does. And the consumer, as you can imagine, it is consuming the messages, and I'm using standard Kafka listener for Spring Boot in this case, where I get notified of any new messages that arrive in Kafka. I get this, and then I start all the calls to some downstream services and some long-running tasks and stuff like this. So really quite simple. How to get this up and running is basically, you could have these applications sitting here and you can use your own applications, but how do you get OpenTelemetry inside of spinning up when you start up the JVM? And for this, I already downloaded the latest version of the Java OpenTelemetry agent. You can find them basically in the Java, in the OpenTelemetry docs. They have great documentation for this. You can go from here. You have sample apps on how you can get started, instrumenting your apps. So I downloaded the Java agent. This is the OpenTelemetry-Java agent.jar file from the GitHub repository from OpenTelemetry. And then I have different run scripts for each of these services. So for the producer, I have a run script. And let me explain what happens here. So what I'm doing here is I have a couple different environment variables that I'm configuring. So for example, I have a Java tool options. And what I'm doing here is I'm just defining the -Java agent. And I'm pointing it to the location where my jar file basically resides. And then I have a couple different other options that I'm defining for the different types of telemetry, like traces, metrics, and logs. You can then configure what should happen if you start up the application and what OpenTelemetry does with that data. So for example, let me quickly maybe just go through an example and just use a console output. So what happens now is I can gather all the telemetry, and in this case, I'm only exporting the traces out to the console. So wait a second, I think since console is the default, let me define these as OTLP. So I'm getting rid of these. Just for now, I'll explain what they do in a second. So I can then spin up the application, start the run file, and hopefully everything works. What was that exception? Console. That is interesting. Do I have a typo? That is weird. So what I wanted to show you is how these traces actually look like in the raw trace information, but for some reason, it is not accepting those. Okay, I guess we need to skip this. Yeah, you can see this is live. So basically, what I'm defining here is I want all of these different telemetry types to be exported as OTLP. OTLP stands for OpenTelemetry Line Protocol. So they will be all exported from the application, and then I can define where to send the data to. And in this case, I'm defining this OTel exporter OTLP endpoint, and I'm just pointing this to our New Relic open OTLP endpoint. And since this is an open endpoint, you also have to define a header, like an API key, basically. And this is what I'm doing here in this OTel exporter OTLP header section. I have an API key, and I'm using, in this case, my New Relic license key as my API key. And then I also can define like a service name. How should this service appear in my whatever observability backend that I'm using? So let me hope that this will work better now. Okay, no exception at least. So this should be up and running in a second. Yes, let's also start the other two services. And for the other two, I did the same thing. I have the consumer as well. I have this run script. In this case, I didn't instrument it. Okay. Well, no, I did. I just had a refresh. Okay. And in this case, I did the same thing. I call this the Kafka Java consumer. Same concept. I'm exporting all the telemetry to OTLP and also for the downstream service. Okay. So now that we have these services up and running, I can then send in some curl requests, for example, somewhere. Okay, cat. So I'm just using, maybe make this a little bigger. So I'm just using a curl request and sending in, I'm sending in a custom JSON, in this case, the order to my service that is running on port 8080, which is the producer. So I can send this in. What will happen is that the producer will pick this up, forward the message into Kafka. The consumer will pick up the message, do all it has to do, and then basically also send the message then back to the producer again. But this is just the way this looks like. And then it also calls this downstream service. You can see it's outputting some information here. So once this is configured and I have this up and running, and I'm sending the data to my request, to my endpoint, I can then try to visualize the data. What do we actually get from this? And let me first also send in some additional data. So this is just the script that using Apache Bench to generate some more messages. You can see it here. I'm using Apache Bench. I have this load gen data JSON, and I'm just generating like 50 requests each second. Okay. So let me go into my New Relic account. And basically, like I mentioned, you can send in the data to whatever target observability backend that you're using, the traces, for example, into Jaeger. In this case, I'm using our New Relic backend. And then we can look at, you may have noticed that I have these three different services here. So the consumer, the producer, and the downstream service. I can click into the producer here. What we typically show is some high-level information about the service, like the response time and so on. But this is not what I wanted to point your attention to. I can then also jump into the tracing, for example, and hopefully I should receive some data soon where we can then look at, what is it actually that we're looking at? So now I got a first trace. So this is a single request that I'm sending in. There will be some more since I'm running this load generation test script. So, and then I can look deeper into this request. And in general, what you will typically see is something like this here on the bottom, or like also at a timeline where you can see this entire request took 4-point-something seconds. How does it break down into different sections within my execution, right? If you remember this diagram, I'm having the producer calling the consumer through a Kafka topic, like not calling directly, and then this calls the Java service and so on. And this is exactly what I can then see here. In total, a single request took like 4 seconds, and where's the time spent? I can see the post to the orders request. Let me make this a little bigger here. So you can see this time, the green one is the time spent in the producer. I'm sending in the data and then into Kafka. Then the consumer, it reads from that topic. And then you can see a big chunk of time spent here. And then I'm also having like 2 different calls to that Java service, the downstream service. I can then look deeper into this request by expanding the consumer side. And then I can actually see there was a GET request to the Kafka service, another GET request to the Kafka service, and then I see something that says uninstrumented time. So what this means is basically that OpenTelemetry at some point decided I cannot or don't want to go deeper into your code and show you what is happening. And this is always for performance reasons. If OpenTelemetry would instrument all of your methods and all of the requests, it would be a huge overhead. And this is what we also did at New Relic with the New Relic agents, but basically OpenTelemetry tries to optimize the visibility into your code. So the good thing is that these applications were up and running with OpenTelemetry very fast. Right? I didn't have to change my application. I just used the Java agent here, defined some configurations, which I can do. I don't need to touch my code. I get it up and running quickly, but it has some limitations, right? I don't know, in this case, 3 seconds out of these 4 seconds are spent in this time, and I have no idea why this is happening, right? Or if there were any exceptions, where did the exception occur? In all of this, the entire trace, was it at the first service or some downstream service? I don't know. But using such a visualization like this here, similar in Jaeger as well, you can then visualize what is happening from a timeline. It shows you where the time is spent. But the auto instrumentation with OpenTelemetry has some limitations. In this case, I don't know what is happening here, right? Why it takes 3 seconds. Does that make sense so far? Any questions on this? One other nice aspect is, so this, like I mentioned, is a single request. You can see this is a single, like a trace ID here that OpenTelemetry initiated. What basically happens is, and maybe I can also show this over here, what we try to generate such a map like this here as well. What happens is that, the producer sends in the data into Kafka. The consumer then reads the data. But how does OpenTelemetry make that happen, that I can continue that trace from the consumer? There's a Kafka topic in between, right? Does anyone know? Or exactly. So what OpenTelemetry does automatically for me is it injects some additional information, and in this case, the so-called trace context. So whenever you make a call like this one here from the consumer to the Java service, maybe I can quickly show you what I did there in the consumer. So I mentioned that I'm calling, downstream service 1, downstream service 2. And if I look at the actual implementation of this, it is just making basically, it's using HTTP URL connection to make a GET request to this URL. This is basically the endpoint of my downstream service. And it gets a response back and visualize it. So what OpenTelemetry does here is, in this case, this is an HTTP request. So it adds some header information like the trace context to that request. The consumer does that, and the downstream service, it receives the request, looks in the header section on, do I have a trace context that someone sent me? If yes, then I'm continuing that trace. And if not, I'm creating a new trace, right? I'm starting fresh from here. But in this case, it identifies that there was something sent in the header section to me as a service, and I can continue that section from there on. And the same thing basically happens also if you have Kafka here in between. So in this case, the producer isn't directly calling the consumer, but it adds some additional context to the message that is sending into the topic. And the consumer side, it receives the topic, the message from the topic, and then looks for that context as part of the message. If it finds one, it continues the trace. If it not, then it starts a new trace. And so the nice thing is that I don't need to deal with all of this. OpenTelemetry did this for me. I didn't have to configure anything, right? It seems almost like magic, but this is the nice way of having an open standard supporting all of these, the trace context that is flowing around in this context. What's also nice is that for this single request, and this is also a standard in OpenTelemetry, I could also look into the logs that have been captured for this entire trace, all the way from the producer to the consumer and the downstream service. So I can look at what are all the logs that we captured in this entire journey. Maybe I have important information in the logs that I'm writing out because my developers, they chose to output some information into the logs. I can also have this available in context with that specific trace. This is not all the logs. This is just the logs for this specific trace that we captured. And it's also, in my opinion, this seems like magic, but this is really the power of OpenTelemetry, because it captures all of this information and puts it in context. So if we then identify this is something that we do, then in some anomalous spans, we can visualize them and say, hey, there was something special here or something took longer than expected. So in this case, one of the spans took like 1,500 something % longer. If we have any errors or exceptions in this entire journey, you can also visualize those, and so on and so forth. But really showing, a nice way I can get up and running quickly, not changing my application, and have a lot of visibility already without me touching the code, which is great. If I want to, I can also look into the some of the metrics. So in this case, what OpenTelemetry, remember, I also configured the traces, the metrics, and the logs. So we also capture some metrics that are being generated out of the box by the JVM, like some JVM-specific metrics, the class count, the CPU count, and so on, whatever, garbage collector. We also capture some Kafka producer-specific metrics. Again, also automatically out of the box, OpenTelemetry tries to identify what are the metrics that are being generated, and it captures those and sends it off to whatever the destination is that you chose. So you can see some, the batch size and so on, some producer metrics and so on. So a lot of metrics that I can then visualize, the record total sent, the byte count, and so on and so forth. And what we then also typically do is show also these Kafka-based metrics for the different producer or consumer things in such a dashboard, again, in context to your application. So the question is, how can we get deeper visibility into this section here, right? Where we saw some uninstrumented time, and OpenTelemetry decided to not go any deeper into my code here. Where's my... Here you go. In this case, we see also some exception. But what I wanted to point out is the uninstrumented time section that for some reason I cannot find anymore. Anyhow, it basically, it looked like this here, right? Where you saw some uninstrumented time and we didn't know why and where's the time spent. And this also then brings me into the manual instrumentation. So what manual instrumentation does is I can have also some dependencies into my application that I'm using. And so for that, let me stop these 3 services here. and I keep Kafka and the rest up and running. And what I'm doing here is I'm just switching to a different branch in this repository. OTel manual inst workshop. There you go. So now if I refresh this and close out some of these files here. So let's have a look at the run script. The run script in this case, why is it not updating? Here you go. That's interesting. Maybe I played around with it. Let's double check. Anyhow, so let me remove this. So this is what the run script looks like. It basically has my Maven wrapper that it actually spins up the Spring Boot application. And then if we look into the application, so I don't have like a Java agent attached to it. But what I'm doing here is I'm adding a couple of dependencies to my application. In this case, in the POM XML, and this also not showing up. So you can see this is live and not any prepared. Here you go. So now for the consumer, I'm basically adding a couple different dependencies here, like all the OpenTelemetry SDKs and APIs that I can use to instrument, to configure certain things like logging, tracing, and so on. I need to add these to my application now. And then in the application itself, in this case, in my Spring Boot app, where's my application? What I'm doing then is I need to define now, okay, what should OpenTelemetry do? So in this case, there's a little bit of code that I had to write to actually define what should be the name of my service. Like this is the service name that we have seen earlier. I can also define like a version for my app. If I have multiple versions deployed, I could also deploy them. And all of this information would be part of the trace metadata that I'm capturing. There's also some, other things that I can define. And then I can also define and implement the different telemetry types like traces, metrics, and logs. And I can be very specific in, what do I want to do with that type of data? I could send it again into like an OpenTelemetry collector pipeline, or in this case, I'm just sending those into an OTLP endpoint. In this case, again, the New Relic OTLP endpoint. I'm using my API key. And the configuration for this is now part of the application properties file. So now I have defined in here some properties for my application that I can read in and then define what should happen to that data. So again, in this case, I'm sending all the OTLP protocol data into our endpoint. Again, this could be Jaeger or Elastic for logs, whatever you chose. But that's unfortunately not everything that I have to do. On the application side, I can then also define when and how do I want to actually create a new trace or a new span in my application. I have, since I'm using the code and all the dependencies of the OpenTelemetry, I can use a construct like this to create a new tracer and define the name on how this trace should be named in whatever system I'm using. And I can then start the span. I can make it the current span. I have a lot of control over what is happening. But this is also the caveat. I need to put this into my code, right? There's also other options that you can use especially in Java, since you can typically use annotations. You can also work with annotations. You could, for instance, say something like this with span, and you can also annotate your apps, and then you don't need to do something like this. So in this way, you could also then tell OpenTelemetry that, hey, this is a method where I want to capture some telemetry, some traces, metrics, and logs from this specific method. I could then also do something like this, where I can then say, for example, maybe I also want to capture, oh, I can type attribute, where I can define that as part of this trace in the metadata of all the things that I'm capturing. I also want to capture the order, if that is something I am allowed to capture, right? And what I'm talking about is, if I then look into any of these traces, there is a lot of metadata that you can attach to it. A lot of it comes out of the box with using OpenTelemetry, like the category, the duration, and so on. There's things like the architecture, the host name, what type of request was it, the HTTP method, and so on. And also the attributes like this, I could then say, as part of this trace, whenever you start a new trace here, please also capture the order as part of my data that I'm capturing. Why is this important? Let me give you an example. So if, for example, imagine you have like a retail scenario, like Amazon, you want to buy something, people can browse products and put them into the cart. If then an exception occurs when your users put something into the cart and you have like 1,000 exceptions, is it only like a certain product that has an issue? Like on these 1,000 exceptions that you captured, are all the products like affected, or is it only maybe a single product? And by capturing, for example, the product category ID or the product ID itself, or maybe some other data like the user ID or a hashed version of the user ID, right? You can then make sure that maybe not only like the exceptions that you get are 1,000 exceptions per one single user, or maybe all of your users, 1,000 users have all one exceptions. So there's a lot of benefit in capturing some additional telemetry, and you can also do this when you do some manual instrumentation by capturing some attributes. And I have an example in the consumer here, where, for example, this is now getting into the details here. You can see I have this execute long-running task that I'm mentioning. I'm just doing a sleep here. And what I'm adding in here is, as part of this sleep span, again, I'm starting a new span that is basically a subspan of this span then. And I can define additional attributes. This is just a use case that maybe works for me, but maybe you have other use cases. And then I can say, hey, this is the name of my attribute, and this is the actual value. It's kind of like a key value pair that I can add. And then maybe I can do something, do some analysis on what happened behind the scenes, and I have some custom data from my applications if I am allowed to capture this type of data. So maybe let's get this new version of the application up and running. I should have still my license key. So let's start the producer, the downstream service, and the consumer again. And this is also what I already prepared. So I have instrumented my consumer, the producer, and the downstream service with some custom manual instrumentation using OpenTelemetry. You can see all of this is just pure OpenTelemetry. I'm not using any any other stuff. So I have a couple imports here for the spans, the tracers, and so on. This is going into the details. If you want to look at the example, this is on my public GitHub. You will find it here. I can share the link after the session as well, where I also have like all the different branches as part of this. So let's get this up and running, and then let's have a look into what we actually receive. Of course, an error message. What was the error? Oh, that is probably the case, yes. I messed around with source code. I think it was in the producer. Where did I mess up the? Here you go. So I don't have the imports for those. So now let's try it again. This is up and running. This is up and running as well. And hopefully, fingers crossed, this as well. Okay, so then we can send in some, orders again. I don't want to run the curl script 1,000 times. So now I'm, generated like, I think 50 orders. 50, yeah, okay. So we should see some data, and now the services, they, send data into Kafka. Consumer receives it and does something with it. Let's have a look into what the different in, the analysis tool, whatever you use, now looks like. I want to point you to the to this here. So previously, when we used manual auto instrumentation, this is the way that auto instrumentation named these traces. It says the HTTP request or the method post and then the /orders endpoint. You will see a difference now whenever we received these new traces because of the fact that I gave it a different name, right? I chose send create order event as the trace name. So hopefully in a second or two, we should see some data here. Still not. So what in general, what happens is that OpenTelemetry batches these requests typically on a 1-minute ratio, and then it sends them in batches so that not every single request that you receive will automatically be sent to your backend. You can customize this, you can define this, but I'm using the defaults here. And then, of course, we on our end, once we receive that data, also do some post-processing. We also use Kafka behind the scenes, basically, but we generate some other metrics. But here you go. So now we received some new traces. You can see at some point, whenever I switch to the new version, I'm getting new names of my traces. Now I'm seeing the send create order event. I can also see, what is the duration of each of these requests. And then I can click into the details. And this does not look correct. I'm saying this does not look correct because I'm only seeing like the Java, the Kafka producer here, and not all the other requests for some reason. Let's wait for a second. Here you go. Now we have some. I can see, how many entities have been involved in any of these traces and how many spans. So let's look into this. So now I see the same picture again. I see, this high-level map. But now if I go into the details here, I can expand like all the different sections from the producer. I can see the create order, the publish into Kafka. On the consumer side, I see the listener, and then all the subsections here, all the way until like my newly instrumented methods, like this execute long-running task. I do this, I see this, why the heck do we sleep here, and so on and so forth. So I can have much deeper visibility into what happens in my code, but with the caveat that I had to do something about it, right? So it's a little bit of a trade-off. You can also have some form of hybrid version so that you can use auto instrumentation, but define certain sections in your application that you want to capture. And how does this look like? I think I have a version of this. Here you go, in the hybrid. So in this, no, not here, on the consumer. let's have a look into the code here. Here you go. So again, this is a mixed version. So I'm using the Java agent from OpenTelemetry, but then I also have a section here, hope you can see it, where I'm defining some additional environment variable called OTel instrumentation methods include. And this way I can define, what are other things that OpenTelemetry does not capture by default, but that I want to instrument. In this case, I'm just have to use the package name, the class name, and then all the methods I can define here. Also, again, without changing my source code, but telling OpenTelemetry that, hey, please include this specific section. And I can have, multiple, oops, I cannot type here. Of course, I can have, comma listed, things of methods that I want to include using OpenTelemetry auto instrumentation, but still capturing some information from my source, from my applications. So it's a mix between both. They all have their advantages, but for example, capturing some attributes is not easily possible using this way. But if I having like a service that is not under my control, I don't have access to the source code, this may be a way to get deeper visibility into your application. Where I'm at, here you go. So again, we see a lot more details here. And what I also wanted to show you is, we looked into some of the traces here, and we also added some custom attributes, and they appear as part of all the other attributes that that OpenTelemetry is capturing by default. But now I see, for example, oh, it's not on this, it's on this level. I'm, for example, seeing all the sleep, for example. I should see. Where's my, here you go. So now I can also, capture some custom data from my applications, and for whatever reason, I could then use this and, leverage this information in the case of like a root cause analysis. Or another aspect is that comes into play. OpenTelemetry comes with a lot of so-called semantic conventions where they have defined what are some standard ways on how to name things. Naming things is always hard. So in this case, what I wanted to show you, and I don't have like a good example here. Let's see. I don't have any errors. Let's go further back in time. Here you go. That is interesting. Anyhow, so what I wanted to show you is what we typically also show is, there's a section here on how many users have been affected and how do you capture this. This is actually also then part of the OpenTelemetry semantic conventions. And they have a lot of conventions in place for traces, metrics, and logs. And for example, also for things like user IDs. So in this case, this consortium has defined, how should we name things in our applications? If we add custom attributes, like the one that we have seen here, where I'm adding the sleep, the amount of sleep time that we're using, like this here, right? They have defined on how should a user ID be named. And in this case, some consortium, they defined that it should be user.id. If you, capture the name of the user, it should be user.name, and so on and so forth. So there's a lot of semantic conventions also part of the OpenTelemetry definition and the spec. Highly encourage you to look into this so that you can, if you want to capture these, that you can make sure that this is based on the standard definition that OpenTelemetry defined for all of this. All right. Any questions so far? I have one more thing that I wanted to show you. So the question is, how could you also capture some data from the infrastructure itself, like from the Kafka brokers and so on? And OpenTelemetry also defines some ways on how this can be done. So in this case, I showed you already that I have, as part of the setup here, I have the OpenTelemetry collector running. And how did I get this up and running? So what I'm using is also a Docker compose file here that I use to spin up this OpenTelemetry collector. Remember this pipeline that I showed earlier, where you can then have receiver, processor, and exporter? This is exactly what these OpenTelemetry collector pipelines basically do. So in this case, this is just the Docker container definition. I'm using the OpenTelemetry collector contributor version in a specific release. This is the behind the scenes. And then I'm also defining this end file here. And here, again, also only have my New Relic license key because I want to export this data, whatever I'm capturing. So, and this then by itself, this container that I'm spinning up, then uses this OTel collector YAML file, where I can then define this pipeline, this receiver, the processor, and the exporter, what basically it should do. And so what I did here is I defined a receiver and OpenTelemetry collector contributor packages. They come with a lot of out-of-the-box receivers. And one of them is a Kafka metrics receiver that you can use. So in this case, I can define the version of my Kafka environment. I can define what type of telemetry do I want to capture, only the broker metrics, the metrics for the topics and the consumer and so on. Again, I have this picture in mind. I have the receiver, I have the processor, and for the processor, I'm only defining that I want to batch all the data. I don't want to directly send them off to a backend. And then I have the exporter defined. And in this case, my definition is just I'm using the endpoint for, again, our New Relic OTLP endpoint. I'm defining the license key and so on. And that's basically it. And then I can, define, this pipeline for the metrics. I could also define, one for the traces and so on, and define specific things here where I want to send the data to. But in this case, I'm only capturing the Kafka metrics for my Kafka cluster that I have running as a container. And then I'm defining, okay, I want to use these Kafka metrics. I want to use this batch processor, and I want to use this OTLP HTTP exporter. Very, very simple. And where did I define the here, the ports and so on for all the different packages. And then as a result of this, I could, for instance, then look into the logs for this container. Oops. And then you can see this is running, it is exporting the data. And now, what does it mean if we receive this kind of data? I can, in general, in New Relic, I can look at all the raw data that we collect. So in this case, I could say, what are all the metrics that I'm receiving? So these are all the metrics. Let's search for some Kafka metrics. And of course, I'm using the wrong account here. Here you go. So now I'm also receiving, on top of the consumer and producer metrics that OpenTelemetry captured from my applications, I'm also now capturing Kafka metrics from my broker itself. So in this case, what are all the brokers that I have up and running? Let me quickly visualize this. Kafka brokers. I can look at the raw data. So these are the raw metrics that we captured from this integration. You can see there's a goal defined with the sum, min, and max. The metric name is called Kafka.brokers. This is the source of it, and so on and so forth. The library, the version of my OpenTelemetry collector. But of course, I don't want to look at raw data. I could also visualize this in a dashboard. And this is what I, in this case, did here, where I just, looked at what are the, different types of metrics that I want to visualize. In this case, I want to see how many brokers do I have currently up and running. This is always dependent upon the time window that I'm looking at, the last 30 minutes. So I have one broker running, I have one partition, one replica, and so on. How does it look like over time, and so on and so forth. So a lot of detailed information that I'm capturing now also from my Kafka infrastructure perspective in all the Kafka metrics itself. If I want to, on top of what we have seen on the application side, where, again, let me go quickly back here. These are the application-specific metrics from the producer and the consumer perspective, right? I could then also, add or correlate this information with the underlying infrastructure metrics and, create some various dashboards that are relevant in my case. Lastly, in case you're also using, Confluent, you're not running your own Kafka clusters itself, there's also a version of this receiver available for Confluent. And in this case, the definition looks pretty similar. So in this case, I'm using a Prometheus receiver for my OpenTelemetry collector. I'm pointing it to a target. So in this case, my API telemetry.confluent.cloud. And since this is a SaaS service, I cannot install anything or capture any other. I need to rely on whatever they expose that I can scrape from them, but they allow to scrape from this endpoint. So I can also define then, this receiver. And again, the same thing applies here. I have a processor and an exporter defined so that I can also capture data from a Confluent cloud environment and have it alongside with all my application-specific metrics. All right. And this is basically, I hope I am still in time, in hour. So I have all of this documented in this slide deck if you want. One thing I didn't mention is one important thing. You may be wondering, in the case of the manual instrumentation, how does Kafka work in this case, right? How do I, still capture that information from the producer through Kafka to the consumer and capture that trace? And for this, what OpenTelemetry provides is a so-called interceptor for the producer side. So you can add this information to your producer config. In this case, this is very Spring Boot specific. So I have an interceptor for the producing side. There's a interceptor for the consumer side as well. And yes, you have to define it. I had a discussion yesterday on, maybe I don't want to capture this information. Maybe I don't want to capture whatever is happening on the consuming side with all the traces that have been initiated on the producer side, because it's not relevant for me, or maybe it just takes too long anyways to process. So, and in this case, if I'm not adding this, I'm not capturing this trace information. So again, I have full control over what is happening here. And then the Kafka metrics and so on. Again, I mentioned it earlier, for the languages in OpenTelemetry, Java is very much supported and very well supported and documented. But there's also the question on various frameworks and libraries that you're using. If you're using some, I don't even know most of these, Apache Dubbo, please have a look into the documentation for this. All of them, they tell you, is this supported with OpenTelemetry? If so, what version? In this case, 2.7 and up is supported. Is it supported in standalone instrumentation? Are there any semantic conventions and so on? It's a huge list of, and this is only Java, right? A huge list of libraries that you can have a look into. You know, is this library and this package already supported using OpenTelemetry? I highly encourage you to look into this link here. And then, you know, it has great documentation here and support. And, you know, if you want to know, can I use this specific library with OpenTelemetry, and does it capture telemetry like metrics, traces, and logs for this specific use case? You know, Hibernate, an ORM mapper, for example. So highly, encourage you to look into this and, check the documentation, because it has great support for many, but maybe not all of it yet, but it is just a matter of time, in my opinion. And I think with that, there's a summary in here in the slide, some reading material, the link to the repository. This is something that Olivia from Confluent shared with me. There's a credit, $400 worth of free credit. And with that, thank you very much for listening. And I'm hoping I'm still in time here. Thank you. Any final questions?
Don't be shy, even if it's in English.
Yeah, I mean, it is the future, in my opinion, right? I mean, if you haven't started, instrumenting applications, looking into traces, metrics, logs, look into OpenTelemetry, because this is and will be the future, in my opinion. And you're not locked in, right? You're doing this once, even if you do custom instrumentation, you're doing it once, but for the right reason. And then you can still choose what do you want to do with the data. Send it to your own, run your own infrastructure for the telemetry, or send it to somewhere else. But I think it is the future, and I would definitely start there if I'm starting from scratch. Yeah, thank you very much.